Let's also take a look at the third category of design patterns, behavioral patterns. So the behavioral design patterns identify typical communication patterns between the objects, clarify assignment of responsibilities between objects, and formalize complex control flow that can be difficult to follow at runtime. So I'd like to give you a couple of examples from this category. So first, let's take a look at the observer design pattern. So here's a typical situation. We have an interesting object with state that we will refer to as a subject inside this observer design pattern. An example of such subject may be an elevator or a floor or an elevator bank. So all of these could be examples of objects with interesting state. There may be a number of objects in the system who depend on the subject state. Okay, so for instance, visitor riding the elevator or visitor visiting a specific floor. So the visitor definitely relies on the information which is available from these types of objects or subjects in this design pattern. So dependent objects would benefit from becoming the observers of the objects of the subject state. So the solution is to let observers register with the subject, and the subject undergoes state changes and notifies the observers. Observer design pattern realizes framework also known as publish subscribe or event listener design pattern. So these are just different names for the same idea. Basically, one object is listening to notifications from another object. So overall structure is like this. So the subject here is an abstract class that provides an interface for attaching and detaching observers. Again, this could be an elevator class, and this could be the visitor or elevator passenger. So notify operation right here basically allows to go through all of the observers, and of course the subject has to keep the collection of all of the observers right here. And it goes through this iteration, and for each of the observer, it just simply calls this abstract method update. So update operation is invoked. So this update allows us to communicate any state changes in the subject to the observer. And of course, we can have a collection of observers. So observer is the interface for all observers who receive notifications from the subject. All right, and of course, because this is an interface or abstract class, and this is also an interface or an abstract class, of course, we have concrete versions of these objects which implement the actual operations and provide the desired functionality. So part of the subject is to be able to attach observers and detach observers. Let's again take a look at the elevator project classes. So here floor and elevator classes have states that the visitor should be aware of. We already mentioned that updates in the system are broadcast through iUpdatable interface. But visitors need to subscribe for updates through visitable interface. So here is an equivalent of attach and detach in this formal observer design pattern structure. In our cases, accept visitor and forget visitor. And of course, visitor is an example of an observer in our version of this design pattern in our own design. So if we wish to animate the elevators running between the floors, we have to recognize two types of visitable places in our environment, which is an elevator and the floor. So they respectively implement the visitable interface right here. The visitors can ask both of these classes to accept or forget them, effectively attaching themselves to the visitable places. So notice that the visitors have a reference to the place that they are currently visiting. So the visitor can communicate with the floor or elevator that they're riding or visiting, but not both at the same time. So there's only one reference to the visitable place from the visitor. So the combination of updatable and visitable interfaces establishes the elements of the observer design pattern, where the visitor is the observer, and floors and elevators, in our example, are broadcasters of their state changes. So each update creates one step in the progress of the animation. An observer design pattern makes system design quite extensible and flexible. For example, if we create a scenario class, right, so we could have another class added to the system. We could call this a scenario class. It could also make itself updatable, right? So it could make itself updatable just like this. And once it happens, it will also receive the updates and react to the changes in the state of the animation. So basically, this simple idea of broadcasting to all of the observers all of the updates that are happening in the state of important parts of this animation can be broadcast to multiple types of objects in the system through this interface. And I would say that since we mentioned the accept and forget idea, or attach or detach, which is basically the same thing, we probably could add to this diagram that the floor has collection of visitors, which is dynamic, right? So we can have multiple visitors that are, so this is an asterisk right here, which are currently visiting the floor, and likewise the elevator will have its passengers collection, which is also made up of the visitors. So of course here we also can have a multiple number of riders or passengers of the elevator. So we could add these types of relationships to this version of the diagram.